I don't know why my face went all the way down there, but I'll put my face up there. All right. Okay. So we looked at the naive method, the moving averages, and the weighted moving averages method. In this video, we'll look at exponential smoothing method. Now, I already had to hide this. Let me unhide this. So you have all of this data. So what I'm going to do is I'm going to call this sheet the naive and moving averages. Right? So the naive and moving averages method here, we'll do exponential smoothing here. Okay, so we'll do two methods in the next one, which is the exponential smoothing method and the trend adjusted exponential smoothing method. Exponential. There you go. All right. So we'll do exponential smoothing with alpha equal to 0.2. Right. So we'll start with the exponential smoothing method. Now, in the exponential smoothing method, the idea is that because you are forecasting, so in the basic exponential smoothing method, when you're making a forecast, the assumption is that there is no trend, there is no seasonality in the data. When you have no trend or seasonality in the data, you basically have a baseline of demand, and what you have around the baseline of demand is essentially random variations, which you cannot capture anyway. Right? So the idea is that any forecast you had in the past is a good enough forecast. That anything else that you do in the future is just an extension of that. So keeping that in mind, what we'll do is, the way exponential smoothing method is done is you always start with the forecast. You say that any forecast is the same as the previous forecast plus some part of the error that you had in the forecast. That's one way to interpret it. Or you say that majority of the new forecast is the previous forecast, but a small part of the new forecast is also coming from the actual demand, because we might not have captured the full scope of the average value of demand around which the random variations are happening, right? So now the one thing that you'll need for the exponential smoothing method is, apart from alpha, you also need the forecast for the first time period. I'm just going to call this F1, the forecast for the first time period, and that, let's say we start with the forecast of 60, right? So I'm going to say we start with the forecast of 60. The first time period forecast is 60. The reason we need this is that anytime we forecast, we're going to base it on the previous forecast. So for us to forecast in the second time period, we will need to know what the forecast was in the first time period, right? So, but we'll do forecast and error at the same time. So the error here will be the difference between the actual demand and the forecast rate, right? Okay. So how do I write the forecast here? So there are two ways of doing it, and I'll show you both. One is you take the forecast of the previous time period plus alpha was 0.2. So you're saying that our forecast is pretty much the same as the previous time period, but we're going to add a small percentage, in this case 20%, of the error that we had in the previous time period. So 20% times the error that we had in the previous time period, that is my new forecast. All right. And similarly, I can calculate error again. Then on the forecast and error, I can copy all the way down, right? So notice these numbers, these are increasingly going to get larger and larger. I'm just going to keep them to 3 decimal places. All right. Now, I want you to notice this 61, 450, 59, 412, and so on. So these numbers are right here. But there's another way of interpreting the same thing. So the other way of interpreting this is, without involving the errors directly, we say that the forecast for any time period is, well, a majority of the forecast should remain the same as the forecast of the previous time period. So if alpha is 20%, you say that 1 minus 20% or 80% of the forecast is the same as the previous forecast, but 20% of the forecast will come from the actual demand that you had in the previous time period, right? So how did I get 80%? So if you say alpha is 20%, the remaining is 80%. So 80% of the forecast is the same as the previous forecast, but 20% of it comes from the actual demand that we have. Why? Because some part of the actual demand might also include some data that we have not included in the average demand, right? So that's it. So 61, 450, it's the exact same number that we got before. So whichever way you interpret it, you'll end up with the same number, right? So I'm going to leave this here because this is the formula the textbook has. So there you go. I'm going to copy this all the way down. Now remember that forecast can go one period in the future, but error has to stop right here. All right. Okay. So even errors, I mean, it's 2 minutes. Let's just keep it to 2. Just keep 2 decimal places. Sorry. So this was the exponential smoothing method. I mean, we can do another example, but the only thing that will change is that instead of using 20% as alpha, let's say I use 10%, this will be 90% and this will be 10%. That's literally the only difference. So I'm going to let you guys figure that out, right? So the next thing we'll talk about is the trend adjusted exponential smoothing. So if you assume that this demand has a very slight trend, let's say that there's a very slight increasing trend in this demand, not a lot, but a small trend, but no seasonality anyway. Now, is that really true? So we saw this in class, but let me quickly show it to you also. So if you insert a line graph, you'll notice that there is a slight increase, a very slight increase in demand, right? So you can also say add trend line. You'll notice that the trend line is also slightly increasing right there, right? Trend line, format trend line. Right? So it'll show you the regression equation and everything, but you don't really need to do any of that. Okay. So that's here. That's a slight increase in data. And there you go. Okay. Right. Now, so what we'll do is we'll do exponential smoothing again. This time we will include the idea that there's a small trend in the data. So we'll say exponential smoothing, adjusted for trend. Right. So again, we will need, in this case, we will need 2 parameters. One is the alpha parameter, which is the exponential smoothing parameter. Let's keep it, let's say 0.1. And then we'll need another parameter called beta. This is the trend parameter. And this, let's say, is 0.2. Right. And on top of this, we will need the first period's forecast, which is 60. Let's say we'll keep it at the same as we had before. And we will need the trend for the first period. So I'll call it T1. Let's say the trend was 0.5. Right. So I'm just going to say 0.5. I think in class I used 1, but I'll just use a different number here. Right. So we have forecast and error. So you know what? Let me just hide. So we are right there. Okay. So we'll do the same here. Forecast. So in this case, we will need forecast. We will need trend. So when you say forecast here, this is forecast without the trend. So we'll have a forecast that does not include trend. Then we'll have a trend portion, and then we'll have something called FIT, or forecast including trend. Right? This is forecast including trend. Right? And then of course we'll have error. So that's forecast including trend. Forecast including trend is just a sum of these two. It's really not that difficult, but here we have. So forecast including. So forecast will be, so first period the forecast was 60 and our trend was 0.5. So our forecast including trend is just a sum of these two numbers. You add the two numbers together and then you're done. Now error will be difference between the actual demand minus the forecasted demand. But again, remember, when you forecast, you are also going to include trend. So this is your final forecast, including the trend. Right? There. So that will be your error value. Right? Okay, now how do I write the forecast here? So the forecast here, so when writing the forecast here, we will use a very similar idea that we used before. So if you remember, when we did, oh, maybe I shouldn't have hidden this, so let me unhide that. So when you wrote the formula here, for example, you said 80% of the forecast was the same as the previous forecast. It's only 20% of the forecast that came from actual demand. So we will use something similar here. So so when you do the forecast, we'll use the exact same idea that we used here, which was that in this case the value of alpha is 10%. So we'll say that 90% of the forecast is the same as the previous forecast. Now when you say previous forecast, we're not talking about the previous forecast, just the regular forecast, but the forecast including trend. This was your final forecast. So 90% of that will be the same as that, but 10% of it will come from the actual demand. So 10% will come from the previous actual demand, that was 67.25, and that will be your forecast without the trend for the first time period. So you always do the forecast first. The reason for that is the trend component depends upon the current forecast, forecast, right? So once you calculate the current forecast, the next idea is to calculate the trend. So when you calculate the trend, so again, the idea is similar. If beta is 20%, then we say that 80%, so 20%, the remaining is 80%. So 80% of the trend is the same as the previous trend. But there might be a small part of the trend that we might not have picked up. So 20% of it comes from a trend correction. And the trend correction is the difference between the current forecast without trend and the previous forecast without trend, right? So this forecast without the trend is calculating the average demand, and the trend is calculating the increase. So that's how these things are working out, right? There you go. So that's your trend, that's your forecast, and your forecast including trend will be the sum of these two numbers. And then you do error, which is the same. Oh, I don't have to do that. I can just copy the formula down right here. There you go. Now, once I have this formula set up for forecast, formula set up for trend, one time each, I can now just copy this whole thing down till the very last time period, right? And I can also do the forecast portion for one more time period in the future. Okay, and now all of these I'm going to restrict to 3 decimal places. There you go, 3 decimal places. Good. All right. So if I was using just exponential smoothing, the forecast was 64,075 gallons. If I'm using with trend, it's 64,543 gallons, right? And these are my error values, and these I'll just keep to 2. I don't need more than 2 for this. Okay, there you go. And that's it. So that's the exponential smoothing method and the exponential smoothing method with trend. So I'm gonna stop this video here. Again, it's longer than 10 minutes already. The next video that I'm going to post, we will talk about error analysis. What I will do is I will use these two methods, the exponential smoothing method and exponential smoothing with trend method. Using both of these methods, we will do error analysis. I'll go over the different types of error aggregation and all of that. All right. So I'll see you all in the next video. Take care.